Here in this question we got a function. Function f is x over x plus 9. It's the ratio of two polynomials, so it's called a rational function. And we know that a rational function is continuous and differentiable in its domain. So domain is all reals except -9, because at -9 we get some 0 on the bottom, and -9 is not in this domain because we are looking on 1 through 18. So does the function satisfy the hypothesis of the mean value theorem? Yes, because this is a rational function and 118 is in the domain. If it does, yeah, that happened, just happened. Now we need to find the number C that satisfy the conclusion of the mean value theorem. Okay, and we know that the mean value theorem says when we have a function that satisfying the mean value theorem, then f prime at that to be determined x value is these are a and b, f of b minus f of a over b minus a. This is slope of secant line. This is slope of tangent line at C. Slope of secant line that connects goes through A and B. Okay, so let me write down the answer here now. F is continuous and differentiable on 118 because this is a rational function and 118 is inside the domain. So optionally we can write domain of f is, what is that, all reals x not equal to -9, because -9 would make the bottom 0, and -9 is not inside 118. So this function is continuous and differentiable everywhere on this domain, and this is in the domain. Okay, so that part is done. And now we want to determine C, pretty much this C. So we want to find its derivative first. Derivative of the function, so we are trying to determine the slope of the tangent line. So it's a rational function. So when we have a fraction u over v, then its derivative is u prime v minus v prime u all over v square. So I'm going to apply this quotient rule. So x plus 9 is square on the bottom. Derivative of top is 1 times the bottom minus derivative of bottom, which is 1 times the top. Okay, let's simplify this. So this is x plus 9 minus x. X plus 9 minus x, so x and x cancel, this 9 over x plus 9 is square. That's the slope of tangent line. Now joining AB, we need to determine slope of secant line. So f of b minus f of a all over b minus a is f at 18 minus f at 1 all over 18 minus 1. So evaluate function at 18. So f at 18 is, we plug in here, 18 over 18 plus 9, 27. 18 over 27 means 9 goes twice, so 2/3, minus f at 1 means 1 over 1 plus 9, 10. 1 over 10 all over 18 minus 1, 17. Let's combine these two fractions. So 2/3 minus 1 over 10. 2/3 minus 1 over 10. So we multiply by 10 over 10. 3 over 3. 10 times 3, 30 is the common denominator. 20 minus 3, 17 over 30. So this is 17 over 30 all over 17, and when we simplify, this becomes 17 over 30 division into multiplication. We can always put 1, so this is 1 over 17. 17 cancels, so 1 over 30. Okay, so 1 over 30 is the slope of secant line, and we already found slope of tangent line here. By the mean value theorem, we know that this should be the same. By the mean value theorem, 9 over x plus 9 quantity squared must be equal to 130. Now from this, we find the value of x. That happens to be the c we are looking for. Cross multiply. So x plus 9 quantity square is equal to 270. Now we got a square. That means let's take square root of both sides. Okay, that gives us x plus 9, in fact absolute value, but we don't write that. We just write plus minus in the right hand side. And square root of 270. 270 is 9 times 30, because I'm trying to write a perfect square number inside. 9 times 3, 27. Yeah, that means 3 root 30. So this is 3 root 30. Now we subtract 9 from both sides. We get x equals, subtract 9, so negative 9 plus or minus 3 root 30. So basically we got two numbers. We need to make sure the numbers lie inside the given interval 1, 18. So that is negative 9 plus 3 root 3, so 30 I meant, and negative 9 minus 3 root 30. Look at this second, negative 9 minus 3 root 30. This is a negative number, and we are trying to find the number inside 118. So this is outside of our range. And what is negative 9 plus 3 root 30? If you punch this number in your calculator, it comes out to be bigger than 1 and less than 18. Okay, just try, and that's the C we are looking for. Thus, the C guaranteed by the mean value theorem is, now we can rename C equals just negative 9 plus 3 root 30, or maybe let's put positive number first, positive plus first, minus 9. And these are unlike terms, so we cannot simplify and never go for decimals. This is the final answer.